It is amazing the math that goes into this animation. The equation governing the motion of these masses is about as simple as you could imagine. The force on the mass is equal to some constant times the position of the mass. In other words, we have this differential equation. And solving this differential equation for the mass starting at position 0 gives you this. The position of the mass is a sine wave. And this is already a beautiful piece of mathematics. Okay, knowing this also gives us the period of the spring, how much time elapses before it repeats itself. Because the sine function repeats itself every 2 pi, our spring will repeat itself every 2 pi over the square root of k. Now let's consider a special spring, one with k equals 1. So its period is 2 pi. So this spring will complete n cycles in 2 times pi times n. And if we want all of the rest of the springs to complete a cycle at the same time that this special spring completes n cycles, then there needs to be some integer that if we take their period and multiply it by that integer, we get 2 times pi times big N. And since the period is given by 2 pi over root k, this is the same thing as saying k equals little n squared over big N squared, which is a rule for picking the k values of the springs. If we pick the k values according to this formula, then at the time that the k equals 1 spring completes big N cycles, all of the springs will be completing a cycle, and they will all be synchronized for just a moment.